Underground cable testing methods. Visual inspection. Though it may seem basic, visual inspection is the first step in cable testing. Technicians check for obvious signs of wear, damage, or corrosion on accessible parts of the cable system. This method helps identify external issues that could indicate deeper problems within the cable. 2. Insulation resistance testing. Insulation resistance testing measures the resistance of the cable's insulation to ensure it is adequate to prevent electrical leaks. Using a megometer or insulation resistance tester, technicians apply a high voltage to the cable and measure the resistance. Low resistance readings can indicate insulation deterioration or moisture ingress. 3. High potential, high pot. Testing. High pot testing involves applying a high voltage to the cable to check its ability to withstand electrical stress without breaking down. There are 2 types of high pot tests. AC high pot testing uses alternating current and is more effective at identifying insulation weaknesses, but requires larger and more expensive equipment. DC high pot testing uses direct current and is more commonly used due to its simpler and more portable equipment. However, it may not detect all types of insulation defects. 4. Partial discharge testing. Partial discharge testing detects small electrical discharges within the cable insulation, which can be early indicators of insulation failure. This method involves applying a high voltage and using sensitive equipment to detect and measure these discharges. Early detection of partial discharges can prevent catastrophic failures. 5. Time domain reflectometry, TDR. TDR is a diagnostic method that locates faults within the cable. By sending a pulse through the cable and measuring the time it takes for the reflection to return, technicians can identify the exact location of faults or breaks. TDR is highly effective for pinpointing issues without the need for extensive excavation. 6. Tan delta testing. Tan delta testing measures the quality of the cable's insulation by assessing the amount of electrical energy lost as heat. A high tan delta value indicates poor insulation quality, which can lead to cable failure. This test is particularly useful for assessing the overall health of aged cables.